Hello gentlemen, welcome back. This is the second video on verifying trig identities. Hopefully you got the hang of it and did some practice from the last video. I'm going to do about 4 more examples in this video here that show a few different tricks or useful strategies to prove some trig identities. Again, it takes some patience, it takes some trial and error. Don't get frustrated. The important part is you start to think through these and using your fundamental identities to verify these, and you get good at that because that'll be helpful down the road. So let's get started. Let's look at this first example. Secant theta minus 1, 1 minus cosine theta equals secant theta. Again, the strategy is to start on the more complicated side. So obviously I'm going to start on this side. And there's nothing that's jumping out on me on this side right here, so I'm probably going to start by converting the secant theta to cosines. And so if I do that, I got 1 over cosine theta minus 1. My strategy here would be to combine these two terms in the top. Let's get a common denominator, which is cosine theta. So if I get a common denominator and combine these two terms in the numerator, I get 1 minus cosine theta divided by cosine theta. So this is my numerator. This is what this section right there reduces down to. Now I have a fraction in the numerator, so I'm going to multiply by the reciprocal in the denominator. So I'm going to go like that. And something nice happens here once I do that. I notice that the 1 minus cosine theta both cancel out, and I'm left with 1 over cosine theta, which is simply equal to secant theta. Okay, so what we did in this one is we went to the cosines, we converted the cosine, got a common denominator here, and then we multiplied by the reciprocal here because we were dividing by 1 minus cosine theta. Okay, hopefully that one makes sense. Again, a little bit different, a little bit more challenging than the ones from the last video. Cotangent cubed x over cosecant squared over cosecant x. A couple things I noticed right off the bat in this particular example. One, this right here is an identity, so I can think about that as cotangent squared. Not sure how I'll use that, but I'm noticing that over here. I still want to start on this side. To me, this side of the equation is a little bit more complicated than this one. But I do note that I have a cotangent squared. This is equal to cotangent squared, so I can rewrite this term as cotangent times cotangent squared, and then all of a sudden I'm going to have this part of the right-hand side of the equation. So I'm going to rewrite the right-hand side as cotangent times cosecant squared minus 1 over cosecant x. Okay? This right here, that term right there, is cotangent squared. So this is still, right here, this expression is cotangent cubed x over cosecant x. Alright, so I'm working on the left-hand side of the equation here. I'm going to leave this part here because it's already in my answer. So I have that. So basically what this problem is now being reduced down to is show that cotan x over cosecant x is equal to cosine x. That's what I'm reduced down to because I already have my cosecant x minus 1. Okay, cosecant squared x minus 1. I already have that. So what can we do here? I leave this term here alone. Cotangent, I'm going to convert this to cosines and sines. So cotangent we know is cosine over sine. 1 over cosecant is simply equal to sine of x. Okay? Because remember, cosecant is 1 over sine. So if I have 1 over cosecant, that's 1 over sine of x, which is equal to 1 times reciprocal of the bottom sine x over 1, which is simply equal to sine x. Okay? So that's where that sine x comes in. Obviously now the sine x terms are going to cancel, and I'm left with cosine x cosecant squared x minus 1. Okay? Again, now we got something with radicals and absolute values, so this is certainly something new. I would start with the radical. Let's see if we can get rid of that. And I'm looking at this, nothing's jumping out on me, but I have 1 plus cosine theta. Let's look at multiplying the top and bottom there by 1 minus cosine theta. Again, just another trick that's going to be helpful to us. Because what the 1 minus cosine theta is going to allow in the bottom is I'm going to end up with 1 minus cosine squared. And I know when I get 1 minus cosine squared, I get sine theta. Okay, so that's why I'm multiplying by that right there. Also on the top, I'm going to get a squared, 1 minus cosine theta squared. So this is what I'm going to get reduced down to. Okay. Obviously, if I take the square root of this, I'm going to get the numerator up here. So I already got the numerator. This right here, this part, that's sine squared. Like that. Okay? Now, if I take the square root, remember square roots are always positive. Okay? Unless I'm solving an equation. I'm given a square root, I get the positive value. The time I get the negative one is if I solve something like, if I say the square root of 4, I ask you for the square root of 4, you tell me 2. But if I ask you y squared is equal to 4, then I get y is equal to plus or minus, y is equal to plus or minus 2. Okay, because I'm solving an equation here. If I just ask for the square root, I always take the positive value. Okay, so here, the top is going to be 1 minus cosine theta over the absolute value of sine theta. Remember, 1 minus cosine theta can never be negative. That's why I don't need an absolute value here, because the maximum value of cosine is going to be equal to 1. Okay, let's do one more example. Secant x minus cosine x equals sine x tan x. What I would do here is I would start still on the left hand side, get rid of the subtractions. It would be easier, and I would start by converting that secant to cosine. I would now look to get a common denominator. The common denominator here is simply going to be cosine of x. So I'm going to get 1 minus cosine squared x over cosine x. Again, this top right there is going to be sine squared of x, like that. What I want to do now is break that sine squared x into sine x times sine x, like that. I note that this part right there, that's equal to my tan x, and I verified it. Okay? So there were a couple more examples, fellas, of verifying trigonometric identities. Here's some more practice for you guys to do. Hopefully you guys get this down, because we're going to need these skills as we start to solve trigonometric equations, which is going to be started in the next video. Okay? So make sure you're emailing me, asking me questions if you're confused. But it does take a little bit of practice. Don't get frustrated. You'll get the hang of it. All right? Have a good day, fellas.